Hello, good afternoon, students.
Good afternoon, madam.
Right. So today we are going to continue the lecture number 5, which is eigenvalues. Right. So I think last week I explained you what you mean by eigenvalues, characteristic values, latent values, and also the proper values. Right. So whenever you are given a matrix like this, how you are going to find the eigenvalues of that particular matrix, right? So if I review very shortly, right? So whenever you are given a matrix like this, right? So if you are asked to find the characteristic values, proper values, or else the eigenvalues, what you have to do is, so along the principal diagonal, so this is the principal diagonal. So in almost all the elements of the principal diagonal, you put minus lambda. For example, so here the diagonal principal diagonal elements are 2, 3, 2. 2, 3, 2. So what we have done is 2 minus lambda, 3 minus lambda, and 2 minus lambda. So last week I explained you how this happens, right? Through this equation, through this expression, how this happens. I'm not going to repeat it again, but very shortly. So whenever you are given a matrix and if you have to find the eigenvalues or else the characteristic values, what you need to do is along the diagonal elements, you need to put minus lambda. Right. So then, so next what you need to do is you need to find the determinant of that particular matrix, which include the lambda for almost all the principal diagonal elements. For example, like this. Right now, you are going to find the determinant. So this thing, right? This particular whenever we find a determinant, so this is the expression, last expression this we call this as characteristic polynomial. And in order to find lambda, what we did is we make this particular equation equal to 0, right? Equal to 0, right? So then when this particular expression equal to 0 here, so that is called characteristic equation. And when we solve this characteristic equation, we will be able to find the respective lambda values. So here after solving this particular equation, so this is a 3-degree polynomial, cubic polynomial. So after solving this, we will be able to find these values. So here the lambda values are 1, 1, 5. So that means 2 eigenvalues have been repeated along with the 1 eigenvalue, which is 5. All right. So the problem we encountered last week is when, so how you are going to solve this particular cubic polynomial. So the one way is, what you can do is, you can perform long division, right? Dirgha bedima. All right. You can perform that in order to find this, or else there are some other techniques where you can find the factors out of cubic polynomial. But however, so sometimes they are very tricky, and some may be competent in solving cubic polynomial, but some may not. So for them, what I suggest is, right, I suggest my own method to solve how you are going to solve a cubic polynomial. That means here we are not going to a cubic level. So whenever we are given a matrix, and so we make almost all the elements of the non-diagonal elements at minus lambda, 6 minus lambda, 3 minus lambda, 3 minus lambda, and equate it to 0, and then we find the determinant. And this is the first expression. So just after we find the determinant. Determinant heavy men lamina, expression make, right? Without doing any further simplification, right? This is the very first expression which we will get from the determinant calculation. So what my recommendation is, so if you further solve this particular expression, the expression solve karo, you will be able to get this cubic polynomial. So rather than coming to this step, that means rather than coming to this step, rather than obtaining the cubic polynomial, what I'm suggesting is to start uh, separating the factors from this step onwards. මේ step එකෙන්ම සාධක කඩන එක ගැන මම ඔයගොල්ලන්ට කියලා දෙන්නම්. Right? So using that method, you will be able to find the factors of this cubic polynomial without doing any long divisions or any other tricky calculations. You will be easily find out the factors of the cubic polynomial, right? So it is your choice whether you are going up to this level and find the factors, or else. So anyone can stop from here, and from this step onwards, you will be able to take out the factors out, and you can simplify the expressions further and find almost all the three factors of this particular equation. So up to that point we discussed last week, right? So the next thing is, so how we are going to proceed further. So I told you last week, right, with respect to these three eigenvalues, right? So that means for each of these eigenvalues, there is a separate eigenvector, right? Separate. මේ හැම eigenvalue එකකටම වෙන් වෙච්ච වෙනම vector එකක් තියෙනවා. It's a 3 by 1 column vector. So that means you may be wondering, so here two eigenvalues are same, 2, 2 and 8 is there. So for you, it seems like there are only two eigenvalues because 2 is repeated here. They can repeat which is going to be with an eigenvalue. But no, but here actually there are three eigenvalues, although the 2 is repeated. So for these two, we have a separate eigenvector. For these two, we have a separate eigenvector. And for this 8, definitely there's a separate eigenvector. So our next step is that. So after accurately finding the lambda, we are going to find the eigenvectors corresponding to each and every eigenvalue. So before that, actually, there are some other tricky calculations where you will be come across within your paper, right? Eigenvalue එක හොයලා eigenvector එක හොයනවා කියන තැනට එන්න කලින් ඊට in between there are some calculations, there are some questions, different formats of questions will be come up. So this is like such question, right? This is a question like this. So we'll go through and understand what is this, right? So now you are given a matrix. The matrix A is defined as A, right? This is a matrix A, and find the eigenvalues of. So initially, so look at this question, right? Right. So look at this question. So in this question, what you ask is to find the characteristic roots or else eigenvalues of this matrix. May matrix එකේ eigenvalues හොයන්න. Right? But here, look at this. When compared to that question, look at this question. Right? This is the matrix A. Rather than saying find the eigenvalues of this particular matrix, what they ask is find the eigenvalues of this particular expression. දැන් මේ A කියන matrix එකේ eigenvalues සෙවීමට අමතරව කියනවා මෙන්න මේ expression එකේම eigenvalues හොයන්න. Right? So that is one sort of a question which you will get within your exam paper, right? So rather than finding the eigenvalues of A, so what they are asking is to find the eigenvalue of 3A cubed plus 5A squared minus 6A plus 2Y. How to do this? So especially, I think you can remember prior solving the eigenvalues, I have told you some properties, important properties of eigenvalues last week, right? So under these properties, we learned that, excuse me, So extremely sorry for the disturbance. So anyway, last week I described you some of the important properties of eigenvalues, right? So there we discussed the first property as, so if we have a square matrix A, right, and if we know the eigenvalues of that particular square matrix, then, and if we ask to find the eigenvalues of transpose of that particular matrix, so both eigenvalues are same, right? Right. For example, if we consider a matrix A, so let's say that the eigenvalues are 1, 2, 3. So then the transpose of A, the eigenvalues of transpose of A also having the same eigenvalues, which is 1, 2, 3. And the second one is the sum of eigenvalues of matrix is equal to the trace of matrix. So last week, we learned what do you mean by trace. And the product of eigenvalues of matrix A is equal to the determinant of A, right? So the product of eigenvalues of matrix A, let's say the three eigenvalues are 1, 2, 3, right? 1, 2, 3. So what is the product? 1 multiplied by 2 multiplied by 3. Eigenvalues තුන 1 2 3 නම් ඒ තුනේ product එක වෙන්නේ 1 වැඩි කිරීම 2 වැඩි කිරීම 3. For example, so that is equal 6. So then also if we check the determinant of that particular matrix, that is also same. And this is the most important part, the fourth part. So there, if the eigenvalues are lambda 1, lambda 2 up to lambda n, for example, in our case, let's say the three lambda values are 1, 2, 3. So you may be wondering why I am always talking about three lambda values. Because we are, in this course, we are mostly considering about the 3 by 3 vectors, 3 by 3 matrices, right? So out of 3 by 3 matrices, as the characteristic equation, we are getting the cubic polynomial. So by solving the cubic polynomial, we will be able to find 3 lambda values. So that is why I'm considering about 3 lambda values always. But you may be, so definitely not for your exam, right? There may be 4 by 4 matrices, 5 by 5 matrices, 6 by 6 matrices, and so on. So if it is 4 by 4 matrix, then there are 4 lambda values. 5 by 5 matrix, there are 5 lambda values, and so on. So with the dimension of the matrix, the number of eigenvalues it has differs, right? So therefore, so let's say in our case, we are mostly go for the 3 eigenvalues case. So there, if our original eigenvalues are 1, 2, 3, so then the first case is, if our original matrix A is going to be multiplied by some scalar constant. For example, let's say our matrix A, we are going to multiply by 2. So what is meant by multiplying the matrix A by 2? So that means we are going to multiply each and every element of the matrix by 2. A කියන matrix එක දෙකෙන් වැඩි වෙනවා කියලා කියන්නේ matrix එකේ හැම element එකක්ම දෙකෙන් වැඩි වෙනවායි කියන එක. Right then, so what happened to the eigenvalues of 2A? So originally for our matrix A, we know that our eigenvalues are 1, 2, 3. So if we multiply our matrix A by 2, so then the corresponding eigenvalues also will be multiplied by 2. So that means 1 multiplied by 2, 2, 2 multiplied by 2, 4, 6, 3 multiplied by 2, 6. So the new eigenvalues of the matrix 2A is going to be equal to 1, 4, 6. Right? So likewise, if we're going to consider any power of our matrix, right? Let's say now our original matrix is A, and now we are going to consider about the A to the power 2. So that means matrix A is going to be multiplied by itself. A වැඩි කිරීම A. So for the new matrix, the new eigenvalues will be powered by the same scalar. So that means if you are considering about the power of A squared, power of 2, A squared, so the new lambda values of A squared matrix is also will be 1 to the power 2, 2 to the power 2, and 3 to the power 2. Right? So then 1, 4, and 9. Right? And the other way, if we consider about the inverse, right? The inverse of the matrix of A, so then the corresponding eigenvalues will be the reciprocal of the original eigenvalues. So the original eigenvalues are 1, 2, 3. So then for the A inverse, we are considering the reciprocal. So that is 1 divided by 1, 1 divided by 2, and 1 divided by 3. So that is the inverse eigenvalues of the A inverse. So by keeping, especially these properties will be important in order to solve our new question, right? This one, right? So what they ask is, so if you closely look at this expression, right? Closely look at this expression. So they are asking, right? 3a cube, right? So now you know, if you know the eigenvalues of A, it will be easy for you to find the eigenvalue of A cube. If you know the eigenvalue of A, it will be easy for you to find the eigenvalue of A square. And also, if you know the eigenvalue of A, finding the eigenvalue of 6A is nothing. And also, you know how to find the eigenvalue of an identity matrix, right? So, with the properties, we are going to start to calculate this. So, the first thing, but in order to commence this particular question, the very first thing what you have to do is first you need to find the eigenvalues of the matrix A, right? Excuse me for a while. Right. So this is the first case. So, first we need to prepare our original matrix. So, this is our original matrix into characteristic polynomial and then characteristic equation. So, here along the principal diagonal elements, we have make it 1 minus lambda, 3 minus lambda, and minus 2 minus lambda. So, now, right? So, now students, right? When you look at this matrix, I'm always telling you, right? I'm always telling you, right? So you always try to find the determinant. You always try to find the determinant. So Dasun has sent this index number to everyone. So I'm asking Dasun, what is the purpose, right? Okay, anyway. So when you look at this matrix or the determinant, right? So always custom to calculate the determinant with respect to the first row, right? With respect to the first row. But if you look at closely, when you look at, if you are going to try if you are trying to get the determinant with respect to the first column, you will identify that. So the two elements are zero there. So you will be having to compute only one element is there to compute the determinant. So it will be easy rather than you consider the first row. හැම වෙලාවෙම first row එකෙන් determinant එක හොයනවට වඩා, so thoroughly examine the metrics that you get, then you will identify what will be the easy columns or rows where you can easily calculate the determinant, right? So then you will be easily get the answer where if you use the first column, right? So finally, so they have ended up, right? They have ended up that the lambda values are 1, 3, and minus 2, right? 1, 3, and minus 2. So then, so our next step. So our question is, so in order to find this, so next thing is, next we are trying to get separately, we are trying to find what is the eigenvalue of A cube, then A square, 6A, and 2I. Then we can consider the whole expression. So if I propose you, so what is the eigenvalue of A cube then? What is the eigenvalue of A cube?
There are 3 answers.
You can't find the 3 answers. Is that so? So then by yourself you can calculate it. Purposely anyway, these are the 3 answers. 1, 3 minus 2. So then A cube. What is the eigenvalue of A cube? Oh.
$327 minus 24.
Sorry?
327 minus 24.
Any different answers to this? One answer as a chat message. 127 minus 8. Any other answers? Okay, so if that is the case, what is the eigenvalue for A squared? For A squared,
194.
194. Then what is the eigenvalue for 6A? 6A. 6A.
618 and minus 2. Minus 12.
Okay. Right. So now you can see. Other than that, what is the eigenvalue of 2i? What are the eigenvalues of 2i? So now you told me eigenvalues of a to the power 3, then a to the power 2, then 6a, then I'm asking eigenvalues of 2i. So what is I?
So unit matrix.
Which matrix?
Identity matrix.
Identity matrix, right. So if I is the identity matrix, so let's forget about 2i. So tell me, what is the eigenvalue of identity matrix? What are the eigenvalues of identity matrix? Identity matrix के eigenvalues बनाओ.
One.
How many eigenvalues are there and what are they? I'm asking. So you are saying 1. 1 means only one eigenvalue and that is 1. Is that so?
Only one eigenvalue, that is 1.
Sorry?
Only one eigenvalue, that is 1.
Only one eigenvalue, that is 1. Say the other answers. Another answer, 2. So I mean, I don't know what is meant by 2. So another answer, 3 ones are there. So I think she's saying 3 eigenvalues are there and those eigenvalues are 1, 1, 1. So any other answers? Right. So I'm asking. So here now the dimension of A is 3 by 3. 3 by 3 square matrix. So right. So then if we are considering, right, so here also A. So then I'm asking, if A is a 3 by 3 matrix, 3 by 3 square matrix, what is the dimension of A to the power 3? What is the dimension of A to the power 3? A to the power 3. A cube කියන matrix එකේ Antima final dimension is here. What is the dimension of a to the power 3? Oh. If a is 3 by 3, then what is the dimension of a to the power 3? So you need to check the dimensions.
3 by 3.
3 by 3. Okay. So then tell me, what is the dimension of a to the power 2 then?
3 by 3.
3 by 3. What is the dimension of 6a then?
3 by 3.
3 by 3. So then what is the dimension of this particular identity matrix then?
3 by 3.
3 by 3. So then, if it is a 3 by 3, right, then how many eigenvalues should be there?
3 values.
3 eigenvalues, and what are they?
There are 1, 1, 1.
1, 1, 1, right? 1, 1, 1. Repetitive eigenvalues are there. So you may be wondering, 1 is the eigenvalue, so there may be 1. එකනම් eigenvalue එක repeat උත් වෙනවා නම් එහෙනම් එකයි වෙන්නේ. එහෙම නෙමෙයි. Dimension එකකින් අපි කතා කරන්නේ. If this particular A is 4 by 4 matrix, so then this particular identity matrix is also 4 by 4 identity matrix. So then there are 4 eigenvalues, that is 1, 1, 1, 4 ones. Right. So here. Now, so they are separately showing us the eigenvalue of a to the power q. As you told me, eigenvalues of a to the power 2. As you told me, eigenvalue of a. So here that is already there, and eigenvalue of I, that is 1, 1, 1. Right. With the help of these things, right? So you know that. So how did you got this eigenvalue of a3, a2? Right? You didn't calculate again. I determinant here. So if you are going to calculate, what you have to do, first you need to calculate a to the power 3. If you do not know the properties which I told you before, properties done so you need to multiply a 3 times, right? A 3 times, and first you need to find out what is a cube, what is the matrix of a cube, and out of that again you need to calculate for eigenvalues. But here we didn't do like that. Using the properties of eigenvalues, we can directly say if a matrix has the eigenvalue of 1, 3, minus 2, then the eigenvalues of a cube is 127 and minus 8, and a squared is 194. Right? And also please remember that the eigenvalues of identity matrix is 1, and if it is 3 by 3, there are 3 ones. If this is 4 by 4, that is 4 ones likewise. If it is 2 by 2, 2 ones. Right? So with this, this is our original question. Find the eigenvalues of 3a cube plus 5a squared minus 6a plus 2y. Right. Now, we are going. So eigenvalues of 3a cube. So 3a cube. Now, remember that. Now, in each case, you have 3 eigenvalues. Eigenvalues 3ක් තියෙනවා. Right? So now, this is your question. Right? Find the eigenvalues of 3a cube plus 5a squared minus 6a plus 2y. So if we consider about, right? If we consider about this whole expression, this is again a matrix, right? Because we have performed addition and subtraction in between same dimension matrix. So can we perform addition or subtraction among different dimensions of matrices? Can we? Can we perform addition in between different dimension matrices?
Yes.
Yes. මං අහන්නේ dimension එක වෙනස් matrices අතර අපිට addition කරන්න පුළුවන්ද? So what is the first bet? No, you can't. Right? So in order to add or in order to subtract 2 or more matrices, so almost all the matrices should have same dimension. ඒක තමයි first principle එක addition සහ subtraction වලදී. So that is the very first principle in addition and subtraction. So that means in order to add 2 or more matrices, or in order to subtract 2 or more matrices, they are in same order. Matrices දෙකක් ඊට වඩා වැඩි ප්‍රමාණයක් එකතු කරන්න හරි අඩු කරන්න හරි යනවා නම් ඒ ඔක්කොම එකම order එකකින් ඉන්නවා. Orders වෙනස් වෙන්න බෑ. or dimension වෙනස් වෙන්න බෑ. Right? So we know that 3a to the power 3 is 3 by 3. 5a to the power 3 is 3 by 3. 6a to the power 3 is 3 by 3. 2i is again 3 by 3. So I told you this whole expression represents another matrix, is also a matrix. So then what is the dimension of this whole expression, matrix represented by this whole expression? What is the dimension of the matrix represented by this whole expression?
3 by 3.
3 by 3. Right? ඇයි අපි එහෙම කියන්නේ 3a to the power 3 is also 3 by 3. Right? So 5a to the power square is also 3 by 3. 6a is also 3 by 3 and 2i is also 3 by. So almost all the individual components, they are 3 by 3. So then definitely we can perform addition and subtraction. So then definitely the final matrix which we get as the result of this is again a 3 by 3. So if the output matrix is also a 3 by 3 matrix, then how many eigenvalues should it have? Should it have?
3.
3. Finally, after output again 3 by 3 matrix එකක්ම නම් දැන් මෙතන අපිට කියන්නේ find the eigenvalues. එතන අපේ final output එක මේ ඔක්කොගෙම represent වෙන final matrix එක 3 by 3 නම් definitely there should be 3 eigenvalues are there. So then we need to separately find out what is the eigenvalue number 1, what is the eigenvalue number 2, and what is the eigenvalue number 3. Adhering to this particular statement. Right? So then as the output, we need to give 3 eigenvalues separately. Right? So that is the basis. Right? So now you know this. Separately, you know what is the A cube, what are the eigenvalues corresponding to A cube, because we know that A cube is also a 3 by 3 matrix. A cube can 3 by 3 matrix, and then there is definitely 3 eigenvalues corresponding to that. If A squared is a 3 by 3 matrix, then definitely 3 eigenvalues are corresponding to that. If A is, we know that definitely 3 by 3, so 3 eigenvalues, and also I, because all these things are 3 by 3, we need to select the identity matrix as 3 by 3, and there are also 3 eigenvalues. So using these 3 eigenvalues, we need to find what are the 3 eigenvalues of this resultant matrix. මෙන්න මෙයාගේ eigenvalues තුන වෙන වෙනම දෙන්න ඕනේ. So this is again the final matrix, right? So what we are doing? So at a time, we select one. So the first we consider about the first eigenvalue in each case. හැමෝගෙම පළවෙනියා ගන්න. Right? We consider first eigenvalue from each case and we apply to this particular expression. 3 times instead of A, we are putting the eigenvalue. A cube with the eigenvalue with the first one, 1 to the power cube plus 5 with an A squared. So here A squared gives first eigenvalue 1, 1 squared minus 6. 6A give first eigenvalue 1 plus 2 times 1. So the first eigenvalue of this whole expression is 4. අපිට මෙයාගේ ඔන්න එක eigenvalue එකක් කියුවා 1 4. Now we are selecting the second eigenvalue, right? Now we are selecting the second eigenvalue in each case. This one, this one, this one, and this one. Right. So this is the second eigenvalue, right? 3 times if a cube, 3 times a cube. A cube is second eigenvalue with the 27. So 3 times 27 plus 5a squared, 5a squared, 5a squared, the second eigenvalue 9. So we substitute 9 here. Minus 6a minus 6, a the second eigenvalue with the 3 plus 2i, 2 second eigenvalue is 1. So when we evaluate this expression, that is 110. So that is the second eigenvalue. Likewise, we are finding the third eigenvalue, right? Likewise, we are finding the third eigenvalue. So which is corresponding to the third eigenvalue in each case, right? So that is this one. And this. So here, so then third eigenvalue, 3 times a cube, 3 times a cube. A cube, the last eigenvalue minus 8. Right? Plus 5 times a square. 5 times a square, the last one, 4. Minus 6a, minus 6, a the last eigenvalue minus 2. Plus 2 times I, 2 times plus 1, 1. So when we evaluate this 10. So then, so the 3 eigenvalues corresponding to this particular expression is 410 and 10. Right? So this is another intermediate type of question that you will get in your final paper in order to check whether you know the properties of eigenvalues. ඔගොල්ලෝ properties දන්නවද කියලා check කරන එක ගානක් තමයි මේක. Right. Now we are coming to our next target. So that is finding the eigenvectors. I told you, right? I told you with respect to each and every eigenvalue, or whether they are repeated or not. Repeat to another for almost all of these eigenvalues. So I got a direct message asking what is the importance of finding eigenvalue. මම හිතන්නේ eigenvalue එක ගැනීමේ වැදගත්කම මොකක්ද කියලා අහනවා. So later on you will understand. So at the beginning of the lecture I told you, right, මම hint එකක් දෙන්නම් මෙහෙම. So if I ask you, right, if I ask you to find, so let's say this is the matrix A, right? So I'm asking you to find a to the power 8. What you will do? I'm asking you to find a to the power 8. So up to now, with the knowledge that you are having with the matrices, what you have to do is multiply the matrix A 8 times. And you know that it is not an easy task. So how even if I give you to multiply 2 matrices, so you will take plenty of time. So if I ask you to find a to the power 8, so then you will be in miserable situation. So for these type of calculations, right, you can easily come to these type of calculations through this lambda, through this eigenvalue calculations. So I will show you at the end of this lecture, so how you can come across that type of calculation, right? So that is one example, or one easily understandable example of importance of taking eigenvalues. Eigenvalues ගැනීමේ වැදගත්කමේ බොහොම සරල example එකක් තමයි මම දුන්නේ. Right. So then characteristic vectors, characteristics, eigenvectors, right? So right, a column vector X is transformed into column vector Y by means of square matrix A. Now we want to multiply, right? So through an example, How another message? How we simply got eigenvalue for that matrix y t same values in the diagonal. Right. So I think you may be asking, right? You may be asking. So you have noticed one thing is it's very good, right? So you have noticed that I don't know all, but some may have noticed that. So this is the matrix A, right? This is the matrix A. So and using the calculations, we have found out these are the lambda values, right? So some have noticed that the eigenvalues we got, right? Eigenvalues we got as same as the components along the principal diagonal element. දැන් ඔයගොල්ලෝ දකින්න ඇති මෙතනදී අපට eigenvalues විදිහට ආවේ කීයද 1 3 minus 2, right? If we closely look at the observe the matrix, you should notice that so the diagonal elements also 1 3 minus 2. Diagonal elements එන්නේ 1 3 minus 2 ම තමයි. සහ මෙතන අපට eigenvalues ඇවිල්ලා තියෙන්නේ 1 3 minus 2. Right? So we'll again go for another example. Right. Now, here this is our original matrix, right? So what are the eigenvalue? What is the principal diagonal components? 6 3 3. 6 3 3. So let's consider, let's look at the eigenvalues we got for this particular 2 to 8. Right, 2 to 8. Although the principal diagonal elements are 6 3 3, that is not equal to 2 to 8. The මෙතනදී principal diagonal elements උයි ආපු lambda values උයි දෙක දෙක. But here in this case, the principal diagonal elements and also the lambda values which we have obtained through calculation both are same. There are some cases like that. So you may be wondering, the මේ ගාන දිහා බලලා හිතන්න එපා. Don't just judge why we need to do such calculations. We can straight away say that the lambda values are equal to the principal diagonal elements. මෙච්චර calculations කරන්න මොකද principal diagonal elements ටිකම අපිට lambda කියලා ලියන්න පුළුවන්. But so that's why I give you two examples. This is not for almost all the cases. හැම matrices එකකම මේක හරියන්නේ නැහැ. So here you should notice that this is a special kind of matrix. So what is this matrix? Any name which can be given to this type of matrix?
Upper triangular matrix.
Okay. So for some matrices, there are some tricky points like that. So if you know and if you notice that this is a particular sort of this is a special kind of matrix, yes, you may say you can obtain the lambda values directly from the principal diagonal elements, but that is not for almost all the cases. හැම matrix එකම ඒ තරකේ අදාළ වෙන්නේ නැහැ. That logic is not relevant for almost all the matrices. Remember that. Right? I think I gave the answer for that question. Right. So here's an example. Right. So now students, now I told you for each and every eigenvalue. So here three eigenvalues 4, 110 and 10. For each and every eigenvalue, there's a corresponding vector. So that vector is a 3 by 1 column vector. Right? Column 3 by 1 column vector. කියන්නේ මේ හැම eigenvalue එකකටම column vector එකක් තියෙනවා. ඒක තමයි අපි හොයන්න යන්නේ. So here is an example. For an example, I'll show you how to find, right? Show that the vector 1 1 2 is an eigenvector of the matrix corresponding to the eigenvalue 2. Right? So now, so the first thing that you need to identify with what you know already. So now you can see this is a matrix where the dimension is 3 by 3. 3 by 3 dimension එකක් තියෙන matrix එකක් මේක. Right. So then there should be 3 lambda values as the eigenvalues. Lambda values තුනක් එන්න ඕනේ. So what they are saying, so we don't know about the other two, but they are saying out of those 3 lambda values, there is so one lambda value is equal to 2. lambda values 3ක් තියෙනවා. 3 ඉතිරි 2 ගැන mention කරන්නේ නැහැ යාලා. But they are saying out of 3 there is a one eigenvalue of one lambda value is 2, and the corresponding eigenvector or the column matrix corresponding to this eigenvalue is this. They what they are asking is to show that whether the corresponding eigenvector of the eigenvalue 2 is 112. මේකට අදාළ eigenvector එක මේකයි කියලා පෙන්නන්න. බව ඔප්පු කිරීම. proof කරන්න තියෙනවා. We need to prove that the eigenvector corresponding to eigenvalue 2 is this one, 112. Right. Right. Okay. So now we again go back to the definition. A column vector x is transformed into column vector y by means of square matrix A. මොකද්ද මේ කියන්නේ? මම හිතනවා මේක මතක ඇති. Right? So, right, whenever you are given, right. 2x1, right? Here now we have three simultaneous equations, right? If we are going to construct a matrix out of these three simultaneous equations, so what is this A1, A2, A3, right? So this is basically the A matrix right here. So out of the set of simultaneous equations like this, so they have created so this A matrix. මෙන්න මේ A matrix එක හදන්නේ කොහොමද? So we create this particular A matrix from the coefficients of these simultaneous equations on the left hand side. So for example in our case, මේ අපේ case එකේදී අපිට තියෙන්නේ මෙන්න මෙච්චරයි අපේ matrix එක වෙන්නේ. This is our A, capital A. So what is A11, 2, A12, 3. Right, A13, 4. Likewise, so we can create using the coefficients of these equations, we will be able to construct our capital A matrix. Right. Right. So what are our x1, x2, x3? x1, x2, x3. Our x1, x2, x3 corresponding to these three simultaneous equations are x, y, z. X, y, z. So what is our y1, y2, y3? 23, 21, 12. So that is capital Y. Right? So for these three simultaneous equations, we have created our own A, own capital A matrix, capital X column matrix, and capital Y column matrix. Right. So now you can see capital A, when we multiply capital A matrix with this capital X matrix, you will be able to get Y. Right? Capital A කියන matrix එක capital X කියන column matrix එකත් එක්ක multiply කරාම ඔයගොල්ලන්ට Y එනවා. So simply that is these three set of simultaneous equations. Right? And also I think last week I told you, so this is the original equation, capital A multiplied by capital X equal Y. Instead of Y, right, Y වෙනුවට, right, last week we put lambda X. Right, instead of this Y, right, instead of this Y, we put lambda X. Right, so that means we can say AX equal lambda X. Y වෙනුවට AX equal lambda X. So that is the basis which we are talking here. Great. Right. Here what they are saying, a column vector X is transformed into column vector Y. The original AX equal Y. Instead of Y, we have lambda X. Right. A column vector X is transformed into column vector Y by use of square matrix A. Simply AX is equal Y or equal lambda X. Now we want to multiply the column vector X by a scalar quantity lambda so that we can find the same transform column vector Y. So actually, then method so if you look at this question, right? If you look at this question, what they are asking, find the vector corresponding to the eigenvalue 2. Find the vector corresponding to the eigenvalue 2. So now you can say instead of this lambda, right? Instead of this lambda, if we put 2, right, 2, then they are asking what is X, right? Lambda වෙනුවට 2 දැම්මනම් ඒ අවස්ථාවේදී අපේ X කීයද කියලා යහන්න. So the X කියන්නේ capital X means in our set of simultaneous equation X, Y, Z. Right? Capital X means X, Y, Z. So here what they have done. So now you can see AX equal here 2X. මේ බව පෙන්නන්න තියෙන මෙතන. So here you do not need to find eigenvector, but they are asking you need to show that AX, capital A, this side, that means left hand side is equal to the right hand side. Right hand side equal කියලා පෙන්නන්න. So you know originally what is A. So let's say we compute left hand side. We compute කරා කියලා හිතන්න left hand side. Left hand side A, we know that is our original A matrix. Right? What is X then? X එක අපිට දීලා තියෙනවා. ඒ කියන්නේ අපේ simultaneous equation එකේ අනුව capital X කියලා කිව්වේ X, Y, Z. Simultaneous equation තුනේ තිබ්බ X, Y, Z. එතන මෙතන X එකවල දීලා තියෙන 1යි, Y 1යි 2යි. So here this is our original A matrix and this is the X matrix, X 1 1 2. Right? If you multiply these two matrices, this is dimension of this matrix is 3 by 3 and dimension of this matrix is 3 by 1. So if we check the dimensions, we can multiply කරන්න පුළුවන් dimension දෙකක් තියෙන්නේ. So when we multiply, we will end up with 3 by 1 matrix. අපි 3 by 1 matrix එකකින් end වෙනවා. So අවසානයේ මේ දෙක multiply කරාම මෙන්න මේක තමයි උත්තරේ 2 2 4. So you can see that. So 2 to 4. So there are same factors if we get 2 out. දෙක කියන පොදු සාධක එළියට ගත්තොත් අපි අවසානයේ ඉතිරි වෙන්නේ 1 1 2. So 1 1 2 again X. So instead of this column vector, we can put 2x. So now you can see the left hand side equal to right hand side, right? So here actually they have given the vector, but in almost most of the cases in the paper, what you need to do is first you need to find the 3 eigenvalues, and you by yourself need to find these kind of 3 eigenvalues, 3 eigenvectors corresponding to 3 eigenvalues. Right? සාමාන්‍යයෙන් වෙන්නේ මේ ගානක මේ තියෙන ගානේ බොහොම කුඩා කොටසක්. සාමාන්‍ය ඔයගොල්ලන්ට වෙන්නේ මෙහෙම eigen vector matrix එක දුන්නාම first you need to find eigenvalues. ඉස්සෙල්ලාම ඔයගොල්ලෝ eigenvalues හොයනවා. Then you need to find these kind of eigenvectors corresponding to 3 eigenvalues. Eigenvalues තුනට අදාළව මෙන්න මේ වගේ වෙන වෙනම eigenvectors තුන හොයන්න. We'll see how to that. Right. And before going to that, there are another set of properties of eigenvectors. Now remember that these are the properties of eigenvectors. So initially, අපි කලින් ඉගෙන ගත්තේ properties of eigenvalues. Right? Initially, we learn about the properties of eigenvalues. But here, we are going to learn about the properties of eigenvectors. Right. First thing, the eigenvector x of matrix A is not unique. Eigenvector x of matrix A is not unique. एक unique नहीं. Right. If lambda 1, lambda 2 up to lambda n be the distinct eigenvalues of n by n matrix, definitely. So we are finding the eigenvalues of a square matrix. ඒක මෙතන n by n matrix කියලා කියන්නේ. Right? අපි eigenvalues දැන් මෙච්චර වෙලා වැඩ කරපුවා අපි හැම matrix එකම square matrix එකක්. So rather than saying square matrix, they are saying n by n matrix. n by n කියලා කියන්නේ square matrix එකක්. So that's why there are lambda values up to n. Right? So if there are 3 eigenvalues, this is 3 by 3 matrix. If there are 5 eigenvalues, this is 5 by 5 matrix. If there are n eigenvalues, definitely there should be n by n matrix. Then corresponding eigenvectors are x1, x2 up to xn. Form a linear independent set. Anyway, then කියන්නේ අපට eigenvalues n ප්‍රමාණයක් තියෙනවා නම් ඒ n ප්‍රමාණයට ගැලපෙන්නම eigenvectors n ප්‍රමාණයක් තිබිය යුතුයි. So in the previous case that you by yourself observe that there are sometimes some eigenvalues have been repeated. For example, 2 to 8. 2 to 8. Although there are 2 eigenvalues are repeated, but there are 3, they are considered as 3 eigenvalues, and those 3 eigenvalues have separated 3 vectors. And if we consider about these 3 vectors, they should be linearly independent. So later on, we will see how to check the linear dependency or independency of this set of eigenvectors. මේ eigenvalue තුනට වෙන වෙනම eigenvectors තුනක් වෙනවා. ඒ තුන linearly independent වෙන්න ඕනේ. මේ කොහොමද මේ linearly independent වෙන්නේ? So how you are going to find whether they are linearly independent or not? Later we will check. Right. So next thing, the third one, if 2 or more eigenvalues are equal, it may or may not be possible to get linear independent eigenvalue corresponding to the equal roots. Right. සමහර වෙලාවට දැන් මේ equal eigenvalues වෙන වෙලාවට, right? So when you get equal eigenvalues, right, then sometimes it may or may not be possible to get linear independent eigenvalues. සමහර වෙලාවට linear independent eigenvalue එකක් මේ equal eigenvalues වලට ගන්න පුළුවන් වෙන්න පුළුවන් බැරි වෙන්නත් පුළුවන්. So that's also, there is no certainty like that. 2 eigenvectors x1 and x2 is called orthogonal. 2 eigenvectors දෙකක් orthogonal වෙනවා if one eigenvalue multiplied by its transpose one eigenvector multiplied by its transpose eigenvector equal 0. අපි හිතමු අපිට එන eigenvectors දෙකක් orthogonal කියලා කියනවා නම් එහෙනම් මෙහෙම condition එකක් satisfy වෙන්න ඕන. So the transpose of the first eigenvector, if we multiply with the second eigenvector, then if they are becoming 0, then we can say these 2 eigenvectors are orthogonal. Right. Fifth property, eigenvectors of symmetric matrix corresponding to different eigenvalues are orthogonal. So now what do you mean by symmetric matrix? We learn about the symmetric matrix and skew symmetric matrix. eigenvectors of symmetric matrix corresponding to different eigenvalues are orthogonal. Take you with. So if there's a matrix, if there's a symmetric matrix, right? So for sometimes symmetric matrices can have repeated eigenvalues. Again, 2 to 8 they can repeat when our side. Sometimes there may be symmetric matrix where their eigenvalues are different, totally different. That means 1, 2, 3. 3 eigenvalues are different. And that situation, at that point, these 3 eigenvectors are orthogonal. And internally, different symmetry may correspond to different eigenvalues are orthogonal. So these are the properties of eigenvectors. So when you compare with the properties of the eigenvalues, the properties of eigenvectors are somewhat tricky. The eigenvalues eigenvectors properties are tricky, but so when you work on, you will understand they will be, right? So normalized form, I'm not going to later on I'll go to, right? So actually that is the end of that part, right? So now we will go to the next lecture where we are going to actually go and find how to compute these eigenvectors. කියන්න එපා එන්නේ කියලා. මම ගොඩක් කතා කරන්නේ. Sorry. Right. So here, right. So here we are mainly talking about 4 types, right? 4 types. So how we come up with the 4 types based on 2 conditions, right? How we come up the 4 types based on 2 conditions, right? So one is symmetric and other one is whether it's repeated or not, right? So up to now, students, you know how to compute eigenvalues, right? You know how to compute eigenvalues. So you know the next step is finding the eigenvectors. In order to find the eigenvectors, we are considering these 4 types. Mainly there are 2: non-symmetric, symmetric, non-repeated, repeated. So out of these 2 combinations, we are come up with 4 types, right? Our stats වල අපි කියන්නේ සංකරණ හා සංයෝජන, right? With the two pairs, we have come up with 4 different types. Non-symmetric matrix with non-repeated, non-symmetric matrix with repeated, symmetric matrix with repeated, and symmetric matrix with non-repeated. Right? These are the 4 types that we are mainly going to consider within this lecture. So under that, first we are coming to the first case. Case by case, we are going to look at, right? Non-symmetric matrix with non-repeated eigenvalues. Remember that this is the easiest. Make a list. Non-symmetric matrices with non-repeated eigenvalues. Eigenvalues repeat වෙන්නේ නැහැ, matrix එක symmetric උත් නැහැ. Right. Right. So now tell me, what are the eigenvalues of the matrix A?
Three, 2, 5.
Why?
Because it's a upper triangular matrix.
Let's see. Yes, they have computed actually. You can compute and see, right? So here also it's easy if you consider about the first column. You are going to get the determinant with respect to first column, right? First column එකට සාපේක්ෂව ඔයගොල්ලෝ determinant එක ගත්තොත් you will be easily end up with this one. And then again it will say lambda is 3, 2, 3, 5. Right. Okay. Now we are going to compute the eigenvectors corresponding to each of these eigenvalues. Then අපි යනවා මේ හැම කෙනෙක්ටම දෙකේ eigenvector එක මොකද්ද? What is the eigenvector of 2? What is the eigenvector of 3? And what is the eigenvector of 5? Now you can see, if you check the original matrix, it is non-symmetric. And if you check the eigenvalues, they are non-repeated. ඒ නිසා මේ title එක හරි කියන එක ඔයගොල්ලන්ට තේරෙන්න ඕන. Non-symmetric with non-repeated. Repeat වෙලා නැහැ. Distinct eigenvalues තුනක් තියෙන මෙතන. 3, 2, 5. කොහොමද වෙන්නේ? Right. This is how to find, right? So you can remember මේකෙන් මෙතනින් අපි පටන් ගත්තේ. Right? So this is where we start. Right? These are the coefficient from the coefficient matrix. Principal diagonal elements wala minus lambda damma. So here is our capital X matrix. Capital X matrix x1, x2, x3 equal 0, 0. Right? Make තමයි අපේ basis එක මෙතනින් එහාට. Right? Now, initially we select the first eigen value which is 2. Then අපි ගන්නවා first case number 1. Eigenvalue 2. So what we are doing is, instead of this lambda, now we know that we have 3 lambdas. So lambda තුනක් ඇවිත් තියෙනවා. As the first case, we can let's pick 2. අපි pick කරනවා 2, and instead of lambda, we are going to substitute 2 in place of lambda. Right? Lambda තියෙන තැන් වල අපි දෙක ආදේශ කරනවා. Right? So when you substitute 2 in place of lambda, so you will get like this: 3 minus 2, 2 minus 2, 5 minus 2. Only this happen along the principal elements along the principal diagonal. But විතරයි -2 යන්නේ. Right? Simply අපි substitute කරන්නේ ආදේශ කරන්නේ මේ lambda තියෙන තැනට දෙක. Right. So when you further simplify these, 3 minus 2 means 1, 2 minus 2 means 0, 5 minus 2 means 3. So now we have come up a new matrix along with x1, x2, x3, 0, 0, 0. So next thing, we write the 3 equations. මෙතනින් අපිට equations තුන ලියන්න පුළුවන්. මොනවද equations තුන? 1 times x1, 1 times x1. Then කලින් කරේ. So initially what we did, they have given the 3 set of simultaneous equations, and out of the 3 set of simultaneous equation we created this thing. අපි මේ format එකට හදාගත්තා. Simultaneous equation තුන දුන්නම using the coefficients of the left hand side we created a, and using our unknown constants we created capital X and Y. So then we are doing the other way around. So that means now we are writing the equations back. Right? Now we are writing the equations back. So how? 1 times x1, 1 times x1, x1, 1 times x2, x2, 4 times x3, 4 times x3 equals 0. Abhi first equation එක ලියුවා. 1 times x1 plus 1 times x2, 4 times x3 equals 0. So second equation, 0 times x1, 0 times x2, 6 times x3 equals 0. Next. Last equation again, 0 times x1, 0 times x2, 3 times x3 equals 0. Right? एक लिया है. Right? 3x3 equals 0. එක ලියන්න අවශ්‍ය වෙන්නේ නැත්තේ ඇයි? Right? If you consider about the last equation, right? Last equation එක යන්නේ අපිට 3x3 equals 0. Right? එතනින් එනවා x3 equals 0. 3x3 equals 0 means x3 equals 0. ඒකම second equation එකනොත් එනවා. So that's why no point නිසා තමයි third equation එක ලියලා නැත්තේ. Right? From the third equation itself, from the second equation itself, we can compute that x3 is going to be equal to 0. x3 into it. Right. Okay. Right? මෙතනදී right here students මෙතන තියෙන්නේ x1 x2 x3 right මම මෙතන මගේ පහසුව සඳහා මම මේක කියනවා xyz කියලා. x1 is x, x2 is y, x3 is z. ඒ විදිහට තමයි මම ගන්න right? So එතකොට first equation එක වෙන්නේ x plus x plus y plus 4z. 4z. Okay, තමයි first equation එක. x1 is equal x, x2 is equal y, and x3 equal z. ඔහොම තමයි මගේ notation එක යන්නේ, right? එතකොට second equation එකෙන් එයා කියන්නේ 6z equal 0. එතකොට මේකෙන් මම ගන්නවා z equals 0 කියලා. එතකොට second equation එකේම මම conclude කරනවා z equals 0. So then මේ z equals 0 කියන එක මම first equation එකේ ආදේශ කරනවා. So I'm going to substitute z equals 0 in the first equation. Then problem with my keyboard. X plus y right. Then if we substitute z equals 0 in the first equation, so then x plus y is equal 0. Then what? Then ඔතනින් එහාට යන්නේ කොහොමද? So what is the next point? So there are no more equations to get any hints or to further solve what is x and y. එතනින් එහාට යන්න බෑ. තව equations හදාගන්නත් බෑ. Both equation 2 and 3 equation දෙකෙන් සහ තුනෙන් කියන්නේ third equation එකෙන් කියන්නේ 3z is equal 0 කියන එක. ඒ කියන්නේ z equals 0. Second equation එකෙන් ගන්නත් පුළුවන් maximum z equals 0. But we need to find what is x and what is y. Then what to do? Right. Then what to do? මෙන්න මේ වගේ වෙලාවක in these type of situations what we consider is, let's say x equal k. අපි කියනවා x කියන්නේ k කියලා කවුරුද? Let's say x is equal k. Then students, what is y? x k ना y මොකක්ද? Go.
minus k.
Minus k. Z මොකක්ද?
0.
0. Right. හරිද? ඇත්තටම දැන් අපි යන්නේ, so actually what we are doing, we are going to find eigenvector corresponding to each lambda value. හැම lambda value එකකටම අදාළ eigenvector එක හොයන්නයි යන්නේ. මොකද්ද මේ eigenvector එක හොයනවා කියලා කියන්නේ? ඇත්තටම eigenvector කියලා කියන්නේ මොකක්ද? What is x? What is y? What is z? So when lambda equals 2, what is x? What is y? What is z? දැන් අපි හොයන්න තියෙන්නේ. What is x? K. What is y? Minus. What is z? We can further solve this. මේක තව දුරටත් solve කරන්න පුළුවන්. What we can do is we take k out. අපි ගන්නවා k එළියට. Here x වල එතකොට k. If we take k out, what is the first value here? X value.
1.
1. Next value?
minus
Y
1.
value? Minus 1. Finally
0.
0. So then the eigenvector corresponding to lambda equals 2 is මෙයා 1 minus 0. lambda සමානයි 2ට corresponding එයාගේ eigenvector එක වෙන්නේ 1 ඍණයක බිඳුව. අපි kව consider කරන්නේ. So if you ask what is the eigenvector corresponding to lambda equals 2. So this is the answer. So this is another different method that they have come across. But same thing. Mama කියලා දුන්නේ. So I told you the easiest way how you come to the solution. Here. This is the eigenvector. 1 minus 1 0. So we'll go to the next eigenvalue. So what is the next eigenvalue? Eigenvalue එකේ දෙවනි eigenvalue එක උනේ 3. lambda 3. අපි බලමු 3ට හදාගන්න. So this is lambda equals 3. So where to start? කොහෙන්ද පටන් ගන්නෙ? So this is where you start. Now instead of lambda you are putting දැන් කලින් දෙක substitute කරගෙන ගියා දෙකට හොයනකොට, right? So since we are targeting lambda equals 2, we substitute 2 in place of lambda. Now we are targeting 3. So in place of lambda, we are substitute 3. In place of lambda, we substitute 3. Lambda තියෙන තැන් වලට 3 ආදේශ කරගෙන යනවා. Here. Can you see? 3 minus 3, 2 minus 3, 5 minus 3. So we further solve this part. 3 minus 3, 0. 2 minus 3, minus 1. 5 minus 3, 2. So the other elements are same as it is. So now this is. So out of this form, we are going to write the equations. The equations, 0 times x1, 0 times x1, 1 times x2 plus 1 times x2, 4 times x3, 4 times x3 equals 0. First equation. So we have finished the first equation. So second equation, 0 times x1 minus 1 times x2, 6 times x3 equals 0. Second equation. Third, 0 times x1, 0 times x2, 2 times x3 equals 0. So again, I'm writing with my notations. For x1 is x, x2 is y, x3 is z. In my case, the equations when 0x plus y plus 4z equals 0. So second equation, 0 times x minus y plus 6z equals 0. Final equation, 2z. Now we need to solve these 3 equations. Definitely you can see ඕගොල්ලන්ට පේනවා. So second equation එක අපි තවදුරටත් simplify කරොත් minus y or else 6z equals y. I 0x ne. So from the last equation we can see z is equal 0. Z bindu I. Right? So now we substitute z equals 0 in the second equation. Z bindu I now y bindu I. Y is also 0. Right? So from the first equation again, අපිට ගන්න පුළුවන්. First equation is also what happened? It's not 0x1, 0x. Right? First equation එකක් reduce වෙනවා y plus 4z equals 0. Make කිසිම තැනක x නැහැ. But although almost all the coefficients of x is 0, එතනින් කියන්න බෑ x බිඳුවයි කියලා. So up to now we sure know z equals 0, y equals 0. But we can't tell anything about x. x ගැන කිසිම prediction එකක් මෙතන දෙන්න බෑ. එහෙනම් මොකද කරන්නේ? We'll say x is equal k. එහෙනම් අපි හිතනවා x කියන්නේ k කියලා. So then එහෙනම් මොකක්ද matrix එක? What is the column matrix? What is the column vector? x value එක ආවේ අපිට k, y value එක 0, z value එක 0. So here also we can take k out. k එළියට ගන්න. දැන් ඔයගොල්ලෝ මෙතන පේනවා k ඉවතට ගත්තොත් 1 0 0. This is the eigenvector of lambda equals 3. Ariba sunlight, right? Now the last one. Antimati tirada in lambda equals 5. Yata thwandone. 5. Again same thing that we are doing. Ekama de karanne, right? So where to start? Here to start. Right? Instead of lambda, now we're going to substitute 5. Right? Now we're going to substitute 5. 3 minus 5, 2 minus 5, 5 minus 5. Right? So 3 minus 5, minus 2, 2 minus 5, minus 3, 5 minus 5, 0. Right? So now we have the new one. So out of this system, we are writing again the system of equations. Minus 2 times x1 plus 1 times x2 plus 4 times x3 is equal 0. So the first equation done. Second equation, 0 times x1 minus 3 times x2 plus 6 times x3 is equal 0. Finally, the last equation, almost all the coefficients are 0. So then 0. No point of writing the third equation. Equation dekai. So if I go to my usual notations, 2x plus y plus 4z equal 0. Then last one, not the second one, minus 3 y plus 6z equals 0. Now, we need to solve these two equations. We need to solve these two equations in order to find three unknowns. Equation dekai, namuth unknowns api hoana tunak x, y, z. What to do? එකක්වත් අපිට hint එකක් නැහැ. දැන් කලින් අවස්ථා දෙකේ in both previous cases x z එක බිඳු වුණා. So in the second case both z and y become 0. But here no hint even for x, y, z. Right? In this case මේ වගේ case එකකදී අපිට උපකල්පන දෙකක් කරන්න වෙනවා. So we need to assume for two variables. Let's say z equal k1 and y equal k2. Or else, right? So the easiest thing is, right? Since we have two equations, right? We can go for one assumption. Let's say Z equal K. Since we have two equations. K. Right? If Z is equal K, what is Y? From the second equation, you can calculate what is Y. Z K now, what is Y?
Two.
Huh? If Z is equal K, what is Y? I didn't get the answer yet. What is Y?
2K.
2K. What you need to do is just substitute here. K කියන එක මෙතන Z කියන තැනට ආදේශ කරන්න. So right. So then if Z is equal K and Y is equal to K, then what is X? What is X? So you need to substitute for the first equation. You need to substitute for the first equation. If Z is equal K, Y is equal to K, then what is X?
Three K.
3K. Now we know all three, X, Y, and Z. Right? So again, X is K, sorry, X is 3K. Z is 3K. Y is 2K. Right? Finally, Z is K. So again, if you take K out here, if you take K out, right, you will end up with 3, 2, 1. The vector is 3, 2, 1. Column vector with 3, 2, 1. So now, for almost all the three lambda values, we have found out the three vectors corresponding to each lambda value. Lambda values තුනටම අපි eigen vectors තුන හෙව්වා. So this is what so this is one of the very easiest questions where show you how to find the eigen vectors corresponding to different eigen values, right? So I think you can remember. Right? So we have four cases, right? We have four cases: non-symmetric matrix with non-repeated, non-symmetric matrix with repeated, symmetric matrix with repeated, and symmetric matrix with non-repeated. So we just finished non-symmetric matrix with non-repeated, and that is the easiest. ඒක තමයි ලේසිම. Right? We just finished, but we need to go for all these three cases, but not today. Right? Because this is the easiest, and that's why you easily come across the solution for the three vectors corresponding to three lambda values, right? පහසුවෙන් මෙන්න මේ කේස් එකේදී ඔයගොල්ලන්ට ගත්තා වුණත් මෙන්න මේ cases තුනේදී that those are going to be tricky. You are not able to come across eigenvectors that much easily. Tricky points තියෙනවා මේ තුනේම. So I'm not going to discuss it today. So we'll keep for the next week. So please go through and please study what you have done up to now. We'll meet next week. So thank you for joining. So you can send me the messages now on. Thank you. Those who have sent me, you can leave the lecture.